Hi everyone and welcome to this week's Cyber Risk Engineering. What can we as information security professionals learn from mathematics around modeling? How can we best absorb the ideas that mathematicians and engineers use to solve real world problems in their world? In this episode, herein. When mathematicians, physicists, engineers have a really hard problem to solve, they try to take it out of the real world and translate it into the math world, produce a number of equations that best describe it. In order to do that, they build a set of assumptions and they try to define very well what it is that their problem can be described as in the math world. So based on the assumptions that they have, they then go off to produce a number of equations, graphs, etc., and then try to solve these equations in the math world. And therefore, they have a number of solutions to bring back to the real world and apply them there. Think of any problem that relates to physics. Think of any problem relating to engineering. This concept of mathematical modeling is basically all around us when it comes to solving problems from the real world into the math world and back. Finally, there's a step of collecting data in order to validate that the model works as it should. That's the basis of mathematical modeling. So how can we use that in the cyber world for the purpose of identifying risk? How can we use mathematical modeling to play similar thought experiments and try to understand the risk that we're in terms of exposing our data and/or our assets when it comes to our organizations? Firstly, we need well-defined threat problems. So what is it that can impact our data and our systems? What are the capabilities of those threat actors? What knowledge do they have? What are they able to hack? Who's sponsoring them? That is the key in terms of understanding this cyber risk world, i.e., what are you trying to protect against? What is the threat problem? And you have to define that really well. Then you have to make some assumptions based on your controls. How well is your environment operating? And typically controls counteract threats. They cancel each other out. So you've got to make some assumptions on how good your controls are. That means that you get to construct a model based on confidentiality, integrity, and availability, another triangle, the CIA triangle, and then look at that model in terms of how are you protecting your data with what controls against those specific threats. And you look at those in the context of the confidentiality, integrity, and availability. So one of the things that you can learn from mathematical modeling is to be able to interpret in your model some solutions and then bring those back to the real world. You should be able to answer questions like, do I need another set of firewalls? Do I need a web application firewall? Do I need further protection on my data, encryption, at rest, in transit, etc.? And all that is dependent on the threats that basically you've looked at the problems in and you've tried to solutionize. Finally, you can run a number of validation exercises, be it through pen testing or red teaming, whereby you're trying to actively mimic operations of hackers and similar threat actors to see how well your model operates in the real world. And there you have it, a link between mathematical modeling and cyber risk modeling. Thank you for watching.